Oh, sorry. Run my SQL query where name is Nick or name does not equal Dave. Ah, it doesn't like my character. So I think, and this is an example of security testing, is you have to try a lot. So maybe they're not using single quotes. So now I can say my name does not equal Dave. Boom. Select star from user table where name is Nick or name does not equal Dave. And so from this I can keep working on the attack. Obviously, most sites are not going to return you the query, but sometimes they have very poor error validation, and you can just try and hammer in something terrible, and it will say, SQL error, unable to execute this query. Now you know the name of the table, and you know the columns in it. So we might come back and keep playing on this. I forgot what my secret was when I set this up last night, but I know it's got to be single quote. So it's got to be where name is Nick, that ends the quote, or name does not equal. There we go. So the trick was I knew it had to fit between these two quotes. So I had to structure my query in a way that it starts by closing off this quote and it ends leaving a quote off. So the result was I get all the secret passwords. If your company is encoding passwords in plain text in the database, run for the hills. There's just nothing good is going to come out of that. But this is just an example. And this is an example of, yeah, I can query other stuff in the same table, but using this concept, right, if you know enough about SQL, I can try and say, I can say, or name in, and I can run a subquery, select star from, from all tables. And you can keep working your way up and digging through the database. And once you have it, and it really only takes one spot, right? They could have done everything they want to protect against SQL injection, but one junior coder or one person that wasn't paying attention puts this unverified data in, and as soon as it's found, it just takes a little persistence once you've found the attack, is to keep working, right? I can start trying to, describe all tables. My next step is to try and get a list of all the tables. Or kind of like what we talked about, if the error messages are including stuff, I might start hammering all their APIs to get feels for what are they calling stuff, what is the terminology inside the company. And then from that I can take a guess. I mean, most stuff isn't that complicated. There's probably a users, there's probably, my company dash users or consumers or things like that. So it's a little fun, it's a little guesswork. So that was an example from the browser. Obviously, you can do it from APIs too if you get a feel that the API is making a request. So here's a general spot. It can come from text inputs on a form like we saw on the Home Advisor form. It can come directly into the API. It can come into stored procedures if your database does it. This is a little trickier, but you still can if you find out that's how they're doing it. It can come from shell scripts. Some companies have like DevOps shell scripts that they run a lot that are somehow accessible by the public or you can kick off. If you can get access to that shell script, it's almost certainly they didn't do a lot of data protection. It's just a simple tool they built to help themselves out, and it has an argument, and you can get in and you can do an entire shell script injection. And this other little guy here, URL parameters. Sometimes you don't even need a form. One thing I would definitely take away from this is as you go through sites, just pay attention to what's happening on the URL. Usually you'll see they're adding parameters, they're adding slashes and stuff to make it easier for you to bookmark and get back to. But seeing that, you might come across a page, like especially search pages. If I try, I think Google does it. We'll try Bing. Right, I can see here, search is cat, this is that. There's a bunch of these other parameters. I didn't enter any of these. There's no reason I can't play around with. Clearly, the site is using them for some reason or other, right? So I can even try and do select star from users. Obviously, Bing is hopefully secure enough not to do that. But it is an example of another place that you can put attacks in, is in this paying attention to the URLs as you go. Okay, so that is SQL injection. Oh, let's talk about how to prevent SQL injection. Obviously, push for standardized libraries. It doesn't take too much searching to see what has built-in protection for SQL injection. And when I say protection, most of the time it is simply don't allow people to put single quotes unescaped. Don't allow them to put semicolons. It's not single and double quotes and semicolons and some brackets that SQL uses. You can let people type it in, but what you do is encode it. So before it gets to the server, you transform it into like an HTML code saying this stands for single quote. And then when you put it back on the site, if you're going to display it again, you change it back. But because of that, it's never in a SQL form when it gets sent to the database. Obviously, again, insist on validation at the client and the server side. The first thing you should do whenever you see a new form on your company site, if it has some sort of, you're not allowed to leave this field blank, you're not allowed to put numbers here, is turn off JavaScript, fill it out, and run it. If that goes through, even security aside, it's a recipe for bad data to get into your site. Push for targeted, limited access for database. Again, we talked about it's fairly easy to set up your super database user, and that's the one the database runs on. You should limit that user's access to the application it's on. You should have multiple database users for each microservice or thing you have, so it can only get to its chunk of the application. So if someone does breach, it's not going to be the end of the world. They still are limited in that. This one is it's not really great to use stored procedures either, but never use a direct query, right? For a number of reasons, but if you've got to interact with the database and you don't have a data access layer, at least push for stored procedures, because that is one way. If everyone is accessing it through this one procedure, you can make sure that's super secure and no one's getting by it. If you're letting people run queries directly from their service, you've got as many people writing queries are potential SQL injection attacks. And one of the big things I like to say is assume you failed. This is one of the biggest things I would say is it doesn't matter how many security bugs you caught or how much you tried. Look at your site from the perspective of somebody who's already gotten through and start looking around for what characteristics that would look like. If I knew that somebody was trying to attack, I could query the database. I can look in the logs to see, are we getting SQL-like things being entered for fields? And then from that, you can go back and show somebody and say, I think either somebody's getting through or they're trying to get through. So always assume you failed in all aspects of life because it prompts you to stay stronger. How to test. We talked about sending it directly through the API. We talked about turning JavaScript off and running that. Check for forms that allow quotes and semicolons and just try and play around with what a query would look like. The good news at your company is you don't have to do the guessing like I did. You can just go to the database, the coders, and say, oh, can I see that code review for that new thing? And just look. Oh, there's a query there. Oh, they're passing in something from the user. I can exploit this. Now you have a choice. You can tell them right there that that's a SQL vulnerability, or you can wait for them to do it and then show off your newfound hacking skills. I'm not here to tell you what to do, but it's probably better to tell them ahead of time. Same thing against stored procedures. You can bypass the client entirely and just security test stored procedures. You can security test APIs. Just be generally aware of how your site is set up. It's an easy question to ask is, hey, when the database is used for this application, what kind of permissions does it have? And if they can't answer, even asking questions can cause your site to be more secure, because if somebody says, oh, I don't really know, it now encourages them, oh, maybe you should. And that becomes the thing people are aware of. And the next time they're setting up a database or a user, they'll be like, oh, yeah, we should make sure it's limited in some way. Okay, so that was SQL injection. The next we'll talk about cross-site scripting. I will note for SQL injection, it's kind of passe now. It was the hotness a long time ago when people were doing direct database access. You don't see it as much, mostly because people aren't interacting with databases in the same way. But it still comes up. A lot of the big issues you see, the big leaks, stem to a SQL injection attack because it's some legacy system they forgot about and come through. But The more popular one now is cross-site scripting. Cross-site scripting is where you trick the browser into running your custom JavaScript. And when I say trick, the real holy grail of cross-site scripting is getting it to store your JavaScript in its database, right? So say I go on Pinterest and I find out they let you put a title for your fancy coaster you're making. And I figure out that they're letting JavaScript through. I put my JavaScript as the title, and then I go and I share it and say, hey, everybody, look at my fancy coaster. And when someone else opens it up on their browser, it's now running code that I wrote. Right? I can do stuff like redirect them to a site that looks just like Pinterest, but is really mine. I could prompt them to say, whoa, your password fell out. Please re-enter your password. All sorts of different attacks like that. And we'll show you an example of this. Same exact principle, but about 10 times worse because there's just so many areas in JavaScript and on the client side where you can inject. It's not just simple queries like a database. Pulling it up, so what I have here is a simple, where is it? A simple site. I have this name ID, username loaded. Yeah, someone puts in the name and they click and it displays the name. So what happens if I look that up, the correct way to do it? Security, put in my name. It says your name is Nick. One of the interesting things about client-side is you can see the JavaScript code. You don't even have to ask the developer for it. I can go and see, hey, what happens when you push this button? Oh, it's calling something called display name. I can go to console and say, hey, what's display name? Oh, there's the code. Fantastic. I can see here, all right, it's let entered name equals, I pulled a value out of the text field. I see that. So, and then I append it to this paragraph element here. And you can see, very similar to the query injection, I'm just appending it in. I'm just throwing it in. I'm not checking if they put anything in correctly. So now I can do the same thing. And then knowing what the HTML is, it's much easier for me. So it's this, I know it's a paragraph element. So I'm going to stick a link element in there. Say, oh, that's the wrong thing. We'll say, my bad site. Go here for fun. And there, assuming this went into the database whenever somebody pulled up my information. And we talked about Pinterest, but it's worse than that. Most companies have some sort of internal tool. So if you can put bad data in on the outside, odds are you can call up their customer service rep and trick them into opening it up, and now it pops up on the inside. And so that's even more dangerous. Right? So I just injected a link onto the page, but it's not even that. I can go and I can say, yeah, I'm going to run a whole script. And it's just basic. Oh, I ran a little pop-up on there. And it doesn't matter if it only allows like 100 characters. You can create a very complex JavaScript thing, and all you have to do is put a URL to it in the script and say, hey, script, run this other script somewhere else. So cross-site scripting is an epidemic, and it is everywhere, and it is very hard to stop because we talked about elements like that. What happens, how you protect against it is they encode all of these characters, like I believe it is, and you'll see this on some websites sometimes. You'll see a lot of and, less than, semicolon. That's how HTML encodes it to try and protect themselves. But there's a ton of different encodings. I don't even know all of them. There's URL encoding where you can try and trick it to decode in the URL and do something. You can do it with scripts. You can try and get an on-click event in, right? We'll see. There's a whole list here. Yeah, here's the basic same idea. I fill in the JavaScript when they click a button. I put in the real one. I shove in some HTML or something to trick them. Very sensitive. Here's that cheat sheet we looked at earlier. This is a very short list, but an example of just all the different places. You can put it in a script, right, if you see that they're doing it there. You can put it inside an HTML comment, right? You can, I don't know why someone would be putting your variable in a comment, but they could, and you can get in there and you could trigger your own HTML. You can put it as an attribute name, right? It doesn't even have to be its own thing. You can put it in a tag name, and you can put it directly in CSS, which is kind of interesting. I wasn't aware that you can sneak it into CSS. So if you're going to find a bug, your first time out, it's going to be through cross-site scripting, and it's going to be fun because what I would recommend, if you ever do find a bug, go to Raptor.js. There's a nice little, dang it, you can download, this is a very simple JavaScript thing. If you can shove this on an element and someone says, I don't think it's a big security issue, show them this raptor running around on their screen and then say, imagine what else you could do, right? I could easily make it look just like the site. I can cause all sorts of problems. I don't even have to try and steal data. I can just make the site, display some sort of horribleness and just ruin your reputation. So cross-site scripting, super fun. Super fun way to check for stuff. How to prevent, you saw that big list, never put untrusted data. Untrusted data is this concept of where are they getting this? Is it from the user? Do you see a function or something that is called to filter out single quotes and greater than and less than signs and HTML type stuff? If your company is doing it, you should push for, again, a standard library that is just known for protecting it, and you should push that they all use it. Another big security issues come from Team 1 has their own version of protecting against it, and Team 2 has their own version, and one of them forgot something. Right? If everyone's using the same, not only can you not be blamed for the problem because you're using what they told you to, but if it's working well, you don't have to worry about it. Another one here is use correct content type headers. There's some weird bugs that you can get. Content type is when you load a page. You can see it through Postman. If you're familiar with APIs, you can say, this API returns JSON, this API returns XML. If your site isn't actually enforcing that, there are ways that people can get an attack through by using an incorrect content type and then tricking it. For instance, if I can say, hey, this is HTML, so the browser says, oh, it's HTML, I'll render it, but it's really JSON, I can put something that the browser will see in JSON, and they'll say, oh, I'm looking for HTML. Oh, there's some, and it will load my script, even though it had been properly escaped and protected against. Standard libraries, use automated tools. We'll talk about that in a little bit, all the different kind of tools you can do. Again, any form that takes input, including hidden. Oh, I should mention that. A lot of forms, if you inspect them, we go to this guy, they have hidden fields on them. Right. I don't see if we'll find one here. But they have hidden information for internal logic or sometimes to prevent cross-site forgery and things like that. If you see a hidden form, you can modify the value. Right. You can do jQuery in pretty much every site, so you can put a selector value, put your own value in there, and then submit the form. So just one thing to note. Pay special attention to alerts on click events. That is anything that uses user data that is on click or an alert or an attribute is especially vulnerable to attack because you don't have to use the less than and greater than brackets. You can get right into the code right there. And then use API calls. It's not necessarily cross-site scripting, but again, if I fill out this form and I just fill it full of different HTML attacks, and then I send it, I can go to the database and say, did they encode it? No, they didn't. Or I can go around the site and see where this form is rendered and see if I was successful getting through. If you're going to do automated tools, usually you focus on the API. You don't really have to do it from the UI level. You find out what the API call this get started is, and you just hammer it with attack after attack after attack to find out what is allowed, what isn't allowed. Okay. Stupid Mac. For some reason I can't get it. Okay, so that's cross-site. There's other types. I wasn't able to set up an LDAP injection, but the same idea, depending how the thing is set up, you'll see sites like this. Example default aspx.user equals. This is kind of an older kind of bug, but still very dangerous if you see it. It might have a user something in there. I can put a star in, and it will run that on LDAP and give me everything back. There's a lot of attacks that involve null characters. This is very specific to knowing about LDAP, but if you see things like aspx.user or user equals, that's a good sign that there's potentially an LDAP attack availability there. And there's a ton of other types of injection that I won't talk about. NoSQL, if you're using Mongo or some other database that doesn't use queries, you're not immune. There's just as many ways to inject a query into a Mongo database. There's just ways to inject something into XML for SOAP UI attacks. Even JSON, we kind of talked about what a JSON attack would look like if they're not using proper content headers. If it's a thing, you can probably attack it. Tips to where to look for. Obviously, any place the user can add information. Again, we talked about the URL. Pay attention to the URL. Look for obscure forms. It doesn't. If you're a hacker, it doesn't matter if it's the least used part of the site. If it's the way in for you, then it's perfect. So look at stuff like contact us, kind of legacy web stuff that people still have around, or email us, or ask a question. Like weird tiny forms that are tucked away in the strange corner of the site. That's where you're probably going to find big problems. Help pages sometimes have things like this, like little search bars have a lot of attacks available to it. Like if I go to Home Advisor, and don't worry, there are no Home Advisor bugs I'll be demonstrating, but you can put something in here, and you might get something like, hey, we could not find this here. Oh, well, maybe I can try a search attack and get there. And if I can get that attack to work, I can see, oh, here's what I put. It's putting in the URL. So say I'm able to make an attack to render JavaScript here. It might seem like, well, that's pointless because only I'm going to see it. This is not writing to a database anywhere, so it's useless for me. But if I can get it to work and it's in the URL, I can easily send this to, call the customer service line. It's, hey, I tried to use your site with this URL. Can you tell me why it's not working? And it starts with Home Advisor, so they're going to click it, and then you're able to run it. So that's a little bit of both social engineering and cross-site scripting. REST APIs, so say basic idea. Again, all of this is on OWASP, just some general tips. So that's it for injection. We'll talk about URL guessing and bad data authorization. This will go really quick. What you'll usually see, and this is an old kind of web kind of system. You'll be like mysite.com, user 1234, item 5456. This is a recipe for problems because if you had the authorization wrong a little bit, the first thing you ever see when you see a user is, oh, what if I go up? What if I go up again? I can't believe there's actually a page called My Site. Yeah, I know. Accidentally hack them. But this is what's called user enumeration. What's the more secure if you're setting up a new thing at all for your company? If you see them trying to use numerical IDs, say no. Say UUIDs, right? Some sort of alphabetical string that it's impossible for somebody to guess what the next in the sequence is. And people do a very good job of protecting this data, but it just takes one gap. And then I could write a script that just says, all right, start with user 1 and work your way up to user 9,000, and I'll grab every user they have in their database as soon as they find a vulnerability. Other types of URL guessing, and again, I don't have an example for this. You'll see this on kind of older Java sites. You see, or PHP is notorious for this. You have your index.html or PHP. Most of the time, the way that's set up is corresponds to a folder structure on their server. So they'll have like users and then something.php. You can guess the folder structure if they haven't protected those files. You can get to their other files. I can say secrets, and then pictures. And if it's there, it'll load it up, and sometimes it'll load it as an index. It's handy enough. It's like, oh, here's the site, here's all the files in that site, go nuts. So it's worth poking around. This is better if you know your company structure, and you can ask them to show you, like, well, hey, how do we render pages? Is there a directory structure involved? And then you can easily write an automated test that just kind of checks that directory structure every time and makes sure somebody can't just waltz in. User info enumeration, yeah. Basically, that's it. If you see a number, go nuts, see what you can get in there. Briefly talking about authorization is sometimes, especially with OAuth and things like that, is weird bugs in authorization can actually be very big security things. You'll see an authorization with it's like a header token you pass in through an API that says authorization basic, a big long string that is some encrypted super secure thing. That's great, but sometimes companies don't bug test for the weird edge cases, and I've seen requests break through with you put authorization as a header, but then you put an empty string or you put a null value. That triggers some weird edge case in their authorization code. It falls out, and you can authorize yourself with virtually nothing, right? So always make sure you check all of those empty string, null, right format, but it's not real, a user, another user. There's a kind of a standard suite of authorization tests for API testing. But by now, you know that. So you have the person making the API request and the data they're asking for. So usually it's, I'm making it and I'm asking for my data. So security attack is, I'm asking for it and I'm asking for someone else's data. Always make sure you're testing that. The next thing we'll talk about really briefly is securing your sessions, session hopping. You've probably run across bugs like this before. It used to be a big thing with Facebook. There used to be a Firefox extension you can pull in and go to a coffee shop, and it would just sniff what's happening, and you can see other people's Facebook information passing. This was obviously because they were using HTTP. You'd probably see a big push for everything to be HTTPS. That's to cover this, but you can also, when you log into a site, it sets a cookie. And I'm sure I've logged into something, so we can see what sites I've been on. If I go to Application and Developer Tools, Cookies, I can, I guess I don't. You can see all the cookies that a site will set. You can dig in that cookie. You can push a cookie through and try and get access to someone else's. And sometimes you have some weird stuff where, I don't know, it might be based on IP. I've seen bugs before where if you open a different browser or the user logs off but the cookie remains and the next person opens it up and it logs them back in. A lot of session-based bugs to test for just kind of around that. And we'll talk about the biggest way to do this is with cross-site request forgery, which will probably be the next thing we talk about. Real quick though, we talk about deep linking. Deep linking is a kind of thing where your bank sends you, hey, your latest statement's available, click this link. That link takes you into the site as a convenience so you don't have to log in, and it loads up your stuff. If you ever are doing something like that through SMS or emails, immediately send it to some other account that's not yours and see, can I get in if I haven't already logged in? Make sure that that is protected. Make sure that deep linking is restricted to only the stuff they're supposed to see with that deep link, right? If it's the statement, I should only get to the statement. I shouldn't be like, oh, now I'm logged in, let's go transfer money. So these are just the kind of common things you'll see, and it's easy to quickly test just to be safe. Obviously for sessions, we talked about copying cookies. You can write a pretty straightforward script. I think I actually have it here. Yeah. Here's a script that's simulating a login for some site. And honestly, most sites, this is what a login looks like. It's a post to a login. You pass a username and password. And what it does is the site sends you back a bunch of cookies that says, all right, you are who you say you are. As long as you carry these cookies around, you're allowed on my site. You should do a test where you, in one session, unrelated to your browser, you grab all the cookies. And then in another one, you push those cookies in and see how far into the site you can get. You really shouldn't be able to, because that's a way for somebody to steal your cookie information and get to it. Your session should be somehow tied to your browser. Right? It should be, this is for this person who logged in, but it's also for this particular browser and this particular circumstance he was in, so someone else can't steal that and spoof in. And there's arguments for and against that. They call it salting the cookie. It honestly hurts automation because you can't jump through like you'd like to, but it's for the best if it means things are more secure. Oh, dang it. All right. So the last big one with the demo we'll talk about is cross-site request forgery. This is, I log into Facebook, everything's going great. Someone sends me an email like, hey, I'm in trouble, go to this website. I go to the website, I know I'm smart enough not to download anything, but I click on the website. That website has a form that sends back a request to Facebook with my cookies now. If Facebook is not properly protected, Facebook will be like, oh yeah, those are the right cookies. I'll run that request for you, and this is the browser you were in last time, so I don't see why I wouldn't want to do that. And to show that, what that looks like, I wasn't able to officially get this to work, again, because a lot of modern servers really have protection against this. I go to evil page. All right, it's just a regular web page, nothing to see here. But if I inspect, what it's actually doing is there's this form here. Right? I've created a hidden form. It's called CSRF form. All it is a single input value, and what it does is, if you were to click this button, which is hidden, it would run this API request. So this is a request to my other site. I called change name, so I'm going to change the name on the site. And then I've hidden it, so it's not possible for them to accidentally click the button. But I also put this little script here and says, hey, as soon as the page loads, submit that form. Right? And this is what forms look like on the site. So it's very hard for the browser, back in the day it was super hard, to know who was making the request. So this would go to Facebook. Facebook would say, this is from the browser I expected to see. This is why you'll see with cookies a lot of times it attaches the domain to it. If your site is not attaching domains, that's a very scary proposition. We'll see how this works when we demo it. Let's see. So I got this little thing. This is, I want to change my name. It's going to say, oh, I'm not authorized, so I have to log in. So this is just a simulated login. Now I can change my name to whatever I want. And then some other point during the day, someone tricks me into going to this page. And this is what it would look like, right? It wouldn't be flashy and full of warnings saying, danger, we're attacking. It would look very plain, and you would say, well, that's dumb. There's nothing on that page. And that's what happens when you click an email. You click a link and nothing happens. It almost certainly is firing out to anything it guesses. They have requests to the major banks, the major social networks. Or just the known. I'm sure there's a list somewhere. If you hear of sites that don't do CSRF protection, so just trick someone to go there. If enough people go, you're bound to hit somebody who has that. So I click there. That's going to send a request back here. So what happens is, this is using Express. Express has stuff to protect it here. So I go there, it's unauthorized me. So it's got, no, you got a request from another domain. I'm taking away your cookie. I'm going to force you to log in again. That's a great feature. I'm pretty sure most modern servers have that too. But if not, there are ways to prevent against it. You want to check for refer and origin headers. If you watch traffic through the network or you make requests through Postman to load your page, it usually has, see if I can do a request to Postman. It usually has, where did this request come from, a refer and an origin. So your website should always check, hey, did it come from us? If not, we're not just going to run any requests just because someone else sent it through a form. So if I go to, what's a good site to go to? That's a post. Well, anyways, you would see it here. Origin and refer. This would be a list of who sent this request through. The other big way to prevent cross-site forgery, and you'll see this if you look at sites, if you look at the HTML behind sites, you'll see hidden fields on forms saying CSRF token. That is a special unique token based on when you went to that forum. So another website doesn't know what that token is, right? They can make a request through a forum, but they don't have that token. That blocks it from going through. So it's not even, you don't have to know much about it. All you have to do is say, hey, are we using CSRF tokens on that? And that's usually enough to force them to do it. You might even get the, well, we are now answer. And you can imagine, what can you do? What's the damage? any form on a website that you can trick to run is anything, right? That's changing passwords, that's transferring accounts. And again, because everything on the client side is public facing, I can look at all of their HTML. I can see this is how they structure their forms. It's very easy. To the fact that just having a CSRF token, even if you don't use it, is probably enough to make the bot skip over you. It's like putting the security sign in your front yard without getting it. So at the very least, get the fake token. Authorization, sorry, I skipped ahead. We talked about this a little bit. Make sure you try different kinds of weird formatting, super long ones. See if you can find a crack in their authorization code, especially since most companies use the same code for authorization across the board. So you want to make double, triple check that is super strong. All right, so that's pretty much the main stuff we want to talk about. I wanted to run through this automated tool in the last 10 minutes, but we'll just run through these last few slides. Know your audience, we talked about that a lot. It's coworkers, it's people inside the company. It's people inside the company don't realize they're doing dangerous stuff. And then the trickiness of once you find a bug, don't advertise it to everybody. Make sure the right people know about it, but you want to be careful, especially if it's a really big bug, because again, you're creating that opportunity for someone to talk about it, unwittingly informing somebody who wants to do damage. So yeah, there's lots of places to look for data, log files, error messages. Error messages is the one that kind of causes contention. If I try and log into a site and it says, your username was correct, but your password is bad, that's a bad error message. I'm informing people way too much data. It should say, login credentials invalid. If you see an error message that says, has a stack trace, that's very bad. If you see a SQL query and they're super duper bad, right? This is all information somebody can pull out of there. So you want to balance a line between being informative, like your request was bad, you need to fix the request body, and saying, here's an example request, here's what you should be putting in there, because you're opening the door for people sniffing around how to get there. Git history, this is all kind of ways to find for the other kind of hackers, again, assuming they got through. Assuming they were successful, what are they going to do once they're inside your network? They're going to look through your Git history. If you made that one test project for a hackathon once and you hard-coded a password in, it's still there. Even if you deleted it, it's still in some commit somewhere. They can dig through the commits and find it. Jenkins, I think, is one of the biggest gaps as people run automated tests. Those automated tests have handy console logs where they print out what it's doing. Those logs sometimes say, I'm entering this password in this field. And that now you've got that. It's encoded for the world to see forever. Confluence and Jira, a lot of things have public Confluence or public Jira. There's very specific implementation details in there. And message boards like Slack. And this is a tough call. You're not going to be the most popular person at the company if you go around yelling at people for talking about the company on Slack and for putting stuff in the Jira ticket. So it's best to strike a balance and just hide the very, very important stuff. If someone has steps to reproduce, say, oh, you probably shouldn't put the password in the steps to reproduce. Something like that. Just try and hide the big stuff. You don't want to be the office bully. In the Google, you can, if you get really into hacking, there's certain terms and stuff that you can search for. Like if I know a common library people use and I know the stack trace that library generates, I can search for a term in that stack trace with the company's name and see if I can find stuff they've posted and logs and stuff like that. Social engineering is what we talked about, the old free USB drive trick. Sweet talking your way in. It is anything where you manipulate somebody to do something just by being a normal human being. Taking advantage of our niceness, like, oh, well, let me open the door for you, or you let someone into the office. So things like that. When we talk about people from inside the company doing damage, always ask yourself, hey, if the janitor came in and plugged one of our network cables in, are they allowed to do whatever they want? Then that's probably not a great idea, right? They might not be able to get into your Git and stuff, but they might be able to get to your Confluence pages and Jenkins and stuff like that. So internal is best, external is not. Internal, you should try as much as you can to treat it as if it was public facing. This is a uphill fight, but it's worth fighting. Always pick your battles, but it's worth making sure people are aware of it. And the best example I give is the janitor. And they would say, oh, why would a janitor do that? It's like, it's not a janitor. It's somebody who wants to hack your company who got a $5 an hour job for 5 weeks to come in and take all your stuff. That's who it is. It's not that. The other common term you'll hear a lot is security through obscurity. That is, oh, no one would ever guess this web URL. It's super unsecure, but only us inside the company know about it. That same idea. As soon as someone knows about it, the odds increase that someone else is going to learn about it just by that knowledge being out there. Assume you've failed. Monitor. Check your logs for large 401, 403s, especially if it's around like a single thing. It's not checking all your APIs. If it's around a single thing, it means somebody thinks there's something there, and they might, whatever gave them that idea, you might want to check as well. Again, wander through your own tests and documentation every once in a while, not all the time, every once in a while, and see, hey, if I just broke into, little make-believe, if I just broke into this company, what would I try and find? Where would I try and look? Just play around like that. And then, yeah, obviously your company probably has security testing companies, or maybe even a whole dedicated security testing thing. But it never hurts to go back through and retest things from time to time. Well, this is where automation obviously makes sense, because changes happen. There's something that was very secure. A bug gets introduced. They don't retest old forms, and now you've introduced a security bug. And then just know your application. You don't have to know all the details, but know the various components that it belongs to, right? Oh, I know we use Apache, I know we use this, I know we use these things in Linux servers. And then you can just Google, what are known security holes, and it'll say, oh, if you're on this version of Linux, you need to upgrade to this or apply this patch, and you can just go ask them, hey, what version are we on? And there you go, you fixed a security bug just like that. Some companies pay like $500 per bug. If you ever get there, what I'll say is you can write a script pretty easily that just goes from server to server to server, checks against a list of known bugs, and says, oh, these 20 servers have these known bugs, and make 10 grand. That is if the server does it. And again, don't try this on a site that you don't have permission for. It is a felony. It's tempting, but don't do it. All right, so real quick, I wanted to talk about tools. The most common one are the easiest one to get started is Zap. It's an open source tool. It's made by the OWASP people. There are paid tools. There are tons of tools that do stuff. They're all fairly good. I think one's LASP or something, a similar name. But Zap is a great way to get started. It's set up for a couple of things. It's set up for a beginner level, and it's set up with more complicated things. What OWASP does when you start it, it sets up a proxy at port 8080. And then if I went to Firefox, and I could configure a proxy, which I don't remember how to do. Probably under advanced. Does anyone know where you set a proxy on Firefox? Oh, it's beside the point. Zap sets itself up. You tell Firefox or Chrome, do a couple of Google searches to say, hey, Chrome, send all traffic through 8080. And all that is it's just taking your traffic and sending it through, but it's monitoring it. So then you go to your website or you run your automated tests, right? You can easily set up this Zap to say, I start Zap, I start my automated tests, I run the whole suite, and it will run a report. It knows what the common things to look for. And it'll say, I watched all your traffic. I think there are bugs here, here, and here. And you get that for free. If you're looking for a FedEx Friday or a quick way to deserve a bonus, that's one of the easiest things you can do. In probably 5 or so days, you could spin up a Zap proxy. If it's the first time you ran, you'll find tons of bugs and you'll look like a hero. Over time, those bugs will stop showing up because it's checking for them so frequently. That's one way to do it. There's a ton of features, but that's one way to get started. The other way I would say is there's just a simple URL to attack. This is one, I don't know what the rules are, but I would not put a website that you don't own, and I would double and triple check you're on your test environment. If you set this attack off, you'll set off alarms in the company saying, whoa, somebody's doing all of these attacks. We're getting something. And it's coming from inside the company, and it's coming from your IP. So make sure you're doing it against something that people know you're doing it and that you've made sure you're on the right environment. Oh, this is running an attack still, sorry. So I'm going to run it against my terrible little security site. There's nothing on there, but it kind of crawls around. Oh, there's tons. See, it's just, hey, see, it found my SQL injection. It found a cross-site scripting. Found some weird X-frame options header application. Password autocomplete in browser. That's an interesting one. So literally, download Zap tonight, point it at your test environment, set it off, and have fun. Do some reading. Read about the attacks. The red ones are the more important. So format them into a nice little email, and enjoy all the kudos for the next day or so. So that is it. Are there any questions?